Hi guys, welcome to the Art of Server. This video is part one of a series of videos where I'm going to be testing the power consumption of LSI HBA SAS controllers, such as the one you see right there. What you're looking at here is my HBA power consumption testing rig, and if you'd like to know more about it, I've made a separate video going over the details of this setup. To see that video, click on the link in the corner here. I'm breaking this video series up into multiple videos because there are a lot of HBA controllers to test. So I've decided to separate them by the number of SAS lanes on the HBA controllers. Today's video will cover all the 8 SAS lane controllers from the first generation SAS 1068E all the way to the 7th generation SAS3808 chipsets. I will skip over the 5th generation SAS 3200 series because they never made an 8 SAS lane version of that chipset. Also, I won't be testing any SAS 4000 series chipset controllers, also known as the 9600 series EHBAs, because there are no 8 SAS lane versions of that controller. If you're curious about the power consumption of 16 lanes, 24 lanes, or 4-lane HBA controllers, subscribe to my channel and stay tuned for those videos in the coming weeks. Also, if you only want to see the test results for a specific card, I'll leave timestamps down in the video description so that you can go ahead and skip to whichever test interests you the most. Alright, so let's get started here. What I have here is a Dell SAS6i, which is based on the first generation LSI SAS1068E chipset. You can sort of guess that this is a pretty low powered card because it doesn't dissipate enough heat to warrant even having a heat sink on that chipset. Power to the card is provided through this PCI interposer board, which draws only from the 6-pin power connection, which is metered over here. So this PCIe reading will show how many watts that PCI card is consuming. Now over here, I have SAS cables connected to the HBA. Now please forgive this SAS cable mess, but I had to use a variety of adapters to convert the SFF8484 connectors to something that could actually connect to these SSDs. These are 8 HGST SAS3 SSDs. We'll be using these to load test the HBAs to see if that affects the power consumption. As a consequence of the load testing, we'll also get to validate the IOPS performance limits of each of these HBAs, except for the SAS3808 chipset because I don't have fast enough SSDs to reach the 3 million IOPS limit. I think it's going to be interesting to see how the benchmark numbers compare to the Broadcom literature. All right, let's go ahead and get in the server. All right, guys, so here I am logged into the server. Let's go ahead and run SAS just to show you guys that the controller is here. All right, so here you will see I have one controller and it is based on the 1068E. So that's the first generation SAS controller. And just as a baseline, if you look at the power consumption right now, it's basically saying about 4 watts, right? So that's the baseline consumption on this card. And so next I'm going to run a FIO benchmark and basically load up the controller with IOPS. And if I run lscsi, you'll see that I have 8 SSDs here connected to it. Now these are SAS3 SSDs, but of course this is a SAS1 controller, so they're only connecting at SAS1 speeds right now. But it's basically drives B through I, okay? And I've set up a file script here, and so you guys can freeze the video if you want to look at all the settings here, but at the bottom here you'll see that I have set it up to run a test on each of those individual drives from B to I. Okay, all right, so let's go ahead and run that. All right, here we go. And we'll keep an eye on the power consumption when we run this. So here we go. So the power consumption is not changing on that PCI card. I mean, if it is, the change is less than a watt, basically. Okay, so that's the conclusion of the test. And if we look under IOPS here, the average IOPS was about 124,500 IOPS. So that's, the performance we're getting out of this first generation chip. And the average bandwidth was basically about 510 megabytes per second. So definitely, in this case, the SSDs can perform much more than this, but the bottleneck is this first generation SAS controller. All right, so that's basically the numbers we have for this generation of SAS controller, and you can see that the power consumption really didn't change much in this case. It's basically sitting pretty steady at 4 watts. All right, I'm going to go ahead and shut down. Let's move on to the SAS1068 controller. All right, so I have the 9211-8i card, which is a SAS1008 controller. All right, so here we are logged in again, and I'm going to run SAS to flash and show you that the controller is here. So you can see that this is a SAS1008 controller, and it's got the latest firmware and all that jazz. So as a baseline, if you look at the power consumption right now, it's sitting about 7 watts right there. Okay, so again, we're gonna run the load test again, and so same exact thing. So let me just kind of show you that I have the 8 SSDs, same exact ones, and we're going to run the FIO script again. All right, let's go. All right, so the system is now under load at around 400 plus IOPS per or IOs per second, or IOPS, and the power consumption. Well, the power consumption jumped a little bit to 8 watts. So under load, it does seem to consume a little bit more power, but not by much. The difference is, it looks like it's sitting somewhere between 7 to 8 watts, right? So this doesn't give me anything like a higher resolution of what the watt number is. But anyway, it jumped a little bit to 8 watts, but it was mostly sat around 7 watts. All right, so let's take a look at the numbers here. So as far as IOPS goes, the average IOPS was about 436, if you round it up, 437,000 IOPS. And we got a bandwidth number of about 1.7, almost 1.8 gigabytes per second. So this is definitely, much improved from the last generation. But as I've mentioned, these SSDs, each of them can do about over 100 IOPS, and so we have 8 of them. So definitely, we are not hitting the IOP limit of the storage, or the storage medium, and so the SAS1008 controller here is obviously the bottleneck, right? So, yep. So anyway, SAS1008 controller is definitely very useful for hard drive use when you don't have a lot of IOPS, but under a heavy IOPS load, this generation of controller will still hinder your performance. So anyway, let's go ahead and move on to the next one. All right, so here I have a 9207 and this is based on the SAS1068 chipset. So this is what we're going to test next. Okay, so let's run SAS to flash here and show you that I have a SAS2308 controller in here, and again, latest firmware and all that. This is that SAS9207-8i controller, and if I run LS1068E, you'll see that I have those 8 SSDs, drives B through I, still there. And as a baseline, we can see that the power consumption right now is hovering somewhere between 9 to 10 watts sometimes. So it's probably in the high 9 watts at idle. Basically, we're not doing anything right now, right? Okay, so let's go ahead and run the IOPS load on it. And here we go. All right, so we're seeing it consistently now at 10 watts. So that's pretty interesting. Yeah, so at idle it was hovering between 9 and 10, mostly at 9. Under load, it's hitting 10 watts. So we're almost done here. Let's see what happens to the power consumption when this is over. Okay, so when the benchmark stopped, it went back down to 9 watts. So I guess under load it does add roughly about 1 watt. Let's take a look at the numbers here. So under IOPS, we have about 595,000 IOPS. And for bandwidth, we have about 2.4 gigabytes per second. All right, so that's it for the SAS2308. Next, let's move on to the SAS3008 controller. So, all right, so here I have the LSI 9300-8i. This is a SAS3008 chipset. This is going to be the next generation after the 2308. So this is what we're going to test next. Alright, so let's run SAS3 Flash just to show you the controllers here. So there we have our SAS3008 controller, and with the 16012 firmware, and this is the 9300-8i. And if I run LS1068E, we should see the same 8 SSDs here from drive B through I. And as a baseline, we can see that the power consumption right now is at about 10 to 11 watts, kind of sticking at 11 more than 10, and that's completely at idle. All right, so let's go ahead and run the benchmark. We'll keep an eye on the power. So it's at 11 right now, and all right, let's run. All right, so we can see the power actually jumped up to about 12. So it is consuming just a tiny little bit, basically like an extra 1 watt of power under load. We're doing roughly 1.2 million IOPS right now, I think. So we'll see what the final average is when this is done. Yeah, controller's still at 12 watts. And we have 7 more seconds. Still at 12 watts. Almost done here. And now we're down to 11 watts. All right, so now that the benchmark is done, we're down at about 11 watts or so. Okay, So IOPS wise average, we averaged about 1.2 million IOPS for the SAS1068 controller. And the bandwidth here is almost 5 gigabytes per second. So, all right, so that's it for the SAS3008. And next up, we're going to do the SAS3408, which is the 9400 series card. All right, so this is the 9400-8i, and this is based on the SAS3408 chipset. And this is the first generation for Broadcom to move to an ARM-based processor. The previous generations were PowerPC. And this is the generation that kind of started energy efficiency improvements. So let's see what happens during the test and what kind of power readings we get for this. But in addition to switching to ARM-based processors, Broadcom also introduced the tri-mode feature, which allows this to work with NVMe drives and basically acts as a virtual PCIe switch. So we're going to test it with SAS3 drives today. We're not going to do NVMe on this, but yeah, this is going to be the next generation. Hopefully we'll be able to see some of the power efficiency improvements here. In the last clip, you probably saw that the 9400 8i card didn't post during the boot up of this machine. And so this has actually been maybe about 2 weeks since that recording because I basically could not get this card to be recognized in the system. And so after several hours of troubleshooting and several days of talking to the people at Elmore Labs and whatnot, basically this card, the 9400 8i, has a difficulty being recognized with that interposer board installed. And the only way that I, after many days of troubleshooting and trying different things, the only way I could get that card to be recognized is to force the PCI slot to negotiate to PCI 2.0 speeds. And so this card won't be able to run in PCI 3.0 speeds while I'm trying to measure the power consumption. So we're going to have to proceed with it running at PCI 2.0 and just, I guess, just note that as a caveat to whatever results we get from it. But anyway, I'm going to go ahead and boot this guy up and force this into PCI 2.0 so that we can proceed with this video. Let me first just show you that the controller is here and actually visible. So previously, before I had to force it to PCI 2.0, the card would not even show up at all. It somehow wouldn't even negotiate down to a lower speed. So I'm not sure why that is, but let me just kind of put that through less. Okay, so here is the PCI information of that card. So it's a 9400 8i, and down here you'll see link capability. It's capable of PCI 3.0 at by 8, but right now you'll see that the link status is downgraded to 5 gigatransfers per second, so that's PCI 2.0 speed. Right, so this is I basically forced it in the PCI configuration of the motherboard. And that's the only way I could get this card to be recognized with that interposer that measures the power. Now, if I put the card into a regular PCI slot without that interposer, it works, but then I can't measure the power consumption. So we'll just have to proceed this way. I spoke to Elmore Labs. They were actually they tried to be very helpful. They even sent me a second interposer board just in case maybe the first one had a manufacturing defect, but that didn't help. I suspect the problem is probably more with the card than it is with the Elmore Labs interposer board. So I don't know. These 9400 series cards seem to be kind of buggy, and I think some people in the comments have said that before too about these cards. So anyway, it is what it is. So we'll just work with it. And oh, actually, I should probably mention that one thing that I'm going to do a little bit differently. We're still going to run the 4K random IOPS read test that I've been running throughout the first part of, the first part of this video. But I think we're going to find out that we're going to overwhelm the PCIe 2.0, and so we're not going to be able to see the full capability or the full IOPS capability. So I'm going to also run the test, and just for this card, I'm going to run it with 2K instead of 4K reads, and so that should give it a little bit more room to basically push more IOPS through that card. So anyway, we'll look at both results. All right, so anyway, just to start with, as a baseline, we are sitting at about 6 watts for this card. And I don't know if running this card in PCIe 2.0 reduces its power consumption or not. But, so I guess keep that in mind, that we're looking at these results with the card running in PCIe 2.0. But anyway, it is sitting at 6 watts, pretty steady at 6 watts right now. And let's go ahead and run the, actually, let me just show you guys that the same SSDs are still here. And we'll run the same 4K random read test on all 8 of those SSDs. All right, so the power consumption is jumping between 6 and 7 watts right now. So it is using a little bit more power, basically kind of like we've been observing with all the other cards so far. It seems to be consuming like 1 watt extra or so under load. The load is looking like it's reaching about 800 plus IOPS, 800,000 plus IOPS right now. I'll let that finish, and then we'll rerun it with the 2K random reads instead. But yeah, the power is fluctuating between 6 and 7. And then, okay, it's over now. And so we had an average IOPS about 820,000 right there. And the total bandwidth used was about 3.3 gigabytes. Okay, so let's rerun this using 2K instead, and I think we'll be able to see higher IOPS with the smaller transaction sizes. All right, so again, it's sitting steady at 6 watts right now, and I'm gonna start the benchmark now. Okay, so it's again hovering between 6 and 7 watts. And you can see already the IOPS here is at like 1.5 million or so. Yeah, so definitely this card is capable of over 1 million IOPS. It looks like about 1.5 million, at least with the 2K random reads. And power consumption is sitting pretty steady between 6 and 7 watts. So this generation really did help reduce the power consumption by going with the ARM architecture. So that's definitely an improvement. Okay, so we're done here. And the average was about 1.5 million IOPS there. And total bandwidth about 3 gigabytes per second. So, all right, so that's it for this test. I'm going to switch the machine back to auto negotiating PCIe link speed for the next generation cards. Those I've already tested actually seem to work fine with the Elmore Labs interposer board. So really the only card that I'm having problem with is this 9400 series. So all right, let's go ahead and shut down. All right, so this is what we're testing next, which is the 9500-8i, and this is based on the SAS1068E chipset. This is the first generation to support PCIe 4.0, and this supposedly can handle up to 3 million IOPS, but as I've mentioned, my SSDs are not fast enough to push that far. I think when we saw the 1.5 million IOPS with the 9400 series card, I think that's about the limit that I'm going to get from those SSDs. So anyway, this is what we're going to go with next. Okay, so let me start with just showing you that this card is here. Okay, so there is the, well, it's cut off here, but it's a 9500-8i right there. And I also want to show you guys that it is PCIe 4.0 capable, so link capability. Speed 16 gigatransfers per second, so that's PCIe 4.0 by 8. Now this motherboard is only capable of PCIe 3.0, so you'll see that the link status is downgraded to 8 gigatransfers per second, which is PCIe 3.0. All right, and if I run store CLI, okay, so here is the HBA 9500-8i and the firmware version that's currently on it. And further down, saw earlier, we have the 8 SSDs connected to that drive. So if I run LSCSI, you'll see the same thing, B through I. And so right now we have a baseline of about 4 watts at idle. And so we're going to go ahead and run the 4K random read benchmark right now. And so right now it's at 4 watts, and let's see what happens. Okay, it's shooting up to about 6 watts. So that's probably the most that we've seen this shoot up, because typically it's like a little bit less than a watt. This is actually somewhat significantly different. So 4 watts to 6 watts is like a 50% increase in power consumption. So it makes me speculate that this generation of cards probably have better throttle control, so to speak, but basically it'll clock down when there's no load and clock up when there is a load. So we're sitting around 1.5 million IOPS so far. Okay, so the test is done and the power consumption went back down to 4 watts. So that's pretty interesting that the power consumption on this generation is a lot more dynamic than what we've seen so far. And here we have the average total IOPS for this test was about 1.4 million IOPS. And like I said, this card is capable of 3 million or so. And I've tested in previous videos, I've tested the RAID version of this card, which is like the 9560 16i. And it did indeed hit some of those numbers. And so I'm pretty sure that this card can handle more. It's just that my SSDs can't. And so we're maxing out at about 1.4 million IOPS here. And the total bandwidth, and again, keep in mind that this is PCIe 3.0, not 4.0, that the card is capable of. But we're hitting almost 6 gigabytes per second there. Okay, so that's it for this test, and this is going to be the last card we're going to test because the 9600 series does not have an 8-port card. But let me shut this down, and we'll put all the results we got from all these tests and kind of discuss. I'll put that in the table and we'll discuss that next. Okay, so here is a table of all the results that we've collected with one additional row here. And let me just explain that real quick, and then we'll kind of go over the results we have here. So as I was putting this table together and putting all the numbers in, this video is primarily focused on the power consumption. And so, you know, that's kind of my main objective in doing the content for this video. But as I was putting together these numbers into this table, I realized that the IOPS numbers and the bandwidth numbers, which is kind of as a consequence of our load testing here. Not really the main objective of this video, but because of the PCIe 2.0 limitation of that 9400 card running in the Elmore Labs interposer, the numbers we're getting were not really comparable to, as far as the IOPS numbers and the bandwidth numbers are not really comparable to the other numbers. And so I wanted to get some numbers that at least were comparable to the other IOPS and bandwidth numbers that we're measuring, even though I won't be able to get the power consumption number. And so I went back and installed the 9400 card directly in the PCIe slot without that interposer board. So I could not measure the power consumption directly. But at least I was able to get some IOPS numbers and bandwidth numbers that I think are a little bit more meaningful in terms of relative to the other numbers that we've measured. So I went back, and that's what this row here is that I'm pointing out right now. That's the one thing that I added to this data set that was not recorded in the prior sections of this video. So anyway, let's go over all the results. So starting at the very top, we have the 1068E controller. This is the first generation LSI SAS controller, and this is a PCIe 1.0 supporting SAS1 3 gigabit speeds, and we used the Dell SAS6i controller, which has the 1068E chipset on it. As far as the specifications I wanted to compare to, I looked up the specifications for the LSI 3081E-R controller, which is the reference controller from Broadcom or LSI back then. Anyway, based on that specification, I got a number of greater than 140,000 IOPS, and so we measured 124.5 thousand IOPS, so coming in a little bit short of that. I don't really know why, but anyway, I think it's within the ballpark, but that's what it is. We got 510 megabytes per second in terms of bandwidth, and I think that's pretty fair for a PCIe 1.0 card. As far as power consumption goes, the specifications for the 3081E-R card didn't really have a real power consumption number. There was one document I found that said PCIe power equals 10 watts. And so that was the only number I could find, and so that's what I have here. I wrote down 10 watts. Again, I don't really know what that means. Does it mean that it needs a PCIe slot with 10 watt specification, or does it mean that that's what the power consumption would be? We measured a idle power of 4 watts, and under load it was basically roughly the same at 4 watts. So this is actually a very energy efficient SAS controller. It is a very old SAS controller, but it is still fairly decent for running SAS spinning hard drives. And so, if you're really going after power efficiency, this might be an option to consider, but it does have its limitations, again, being PCIe 1.0, supporting only SAS1 3 gigabits per second. It's definitely not suitable for most SSD arrangements. And it does have a 2 terabyte drive size limit for SATA drives. So if you are using modern SATA drives, it's probably not the right choice. But that limit doesn't exist, or it's a much higher limit at 8 zettabytes for SAS drives. So if you are using SAS hard drives only, this might be something to consider if you're after that 4 watt idle power, or even under load, right? So, all right. So moving on to the next generation, we have the SAS1008. This was the 9211-8i controller. This is the first generation controller to run PCIe 2.0, as well as supporting SAS2, which is 6 gigabits per second. And the rating for this controller, the 9211-8i, was according to the documentation, is supposed to be greater than 320,000 IOPS, and we came in significantly higher than that at 436.8 thousand IOPS. So that's pretty incredible. We got a bandwidth number of roughly 1.7 gigabytes per second, and as far as power consumption is concerned, the documentation specifies a nominal power consumption of 8.04 watts with a worst case scenario of 14.63 watts. I don't really understand what the worst case scenario is or how that would be achieved, because under load, we basically saw the power consumption change from 7 to 8 watts, right? So it's not really anything close to 14. But again, I don't know what worst case actually means. But if you compare it to the nominal power consumption number, I think we're pretty spot on in terms of the power consumption numbers that we measured. Okay, so moving on to the next generation, we have the SAS1068, which is the 9207-8i card. This is the first generation to support PCIe 3.0, but again, supporting SAS2 6 gigabits per second. The official rating for this controller is greater than 650,000 IOPS. The number we measured was 595.1 thousand IOPS, so we're coming in a little bit short of that. The bandwidth number we got was about 2.4 gigabytes per second. And as far as power consumption goes, the specified nominal power consumption was 9.8 watts with a worst case scenario of 16.0 watts. The measured numbers that we got was basically 9 watts at idle, and that went into the 10 watt territory under load. And so I think the numbers that we're measuring are pretty spot on to, if you compare it to the nominal 9.8 watt number from Broadcom's documentation. So moving on to the fourth generation, this is the SAS1008 or the 9300-8i controller. This is the first generation controller to support SAS3 12 gigabits per second SAS protocol. It is still a PCIe 3.0 card. And the IOPS number for this was not as specific as previous generations, but they basically said greater than 1 million IOPS. So I wrote down greater than 1,000K, right? And the number that we got was actually pretty good. It was roughly 1.2 million IOPS, basically. And so definitely above the 1 million IOPS that they specified. And we got almost 5 gigabytes per second in bandwidth. And the power consumption, the documentation specifies a nominal power consumption of 13.0 watts with a worst case scenario of 19.04 watts. And the numbers that we measured was basically idle power consumption of 11 watts and going into the 12 watt territory under load. Power consumption numbers are actually coming in lower than what the specifications are. As you can see, these first 4 generations of controllers, if you kind of look at the progression, the performance is going up, but also the power consumption is going up as well. And I think Broadcom was, of course, very aware of this, and they were looking for a solution to bring down that power consumption. And so in the following generation, which is the 3408 chipset or the 9400-8i controller that we had some problems with, this is the first generation to support or to switch over to an ARM architecture. All the previous generations were based on a PowerPC chip. This is the first generation to switch to an ARM chip, and ARM being known for being power efficient, I think was probably the primary objective of Broadcom moving to ARM. This is the generation that still supports SAS3 12 gigabits per second. It's still a PCIe 3.0 card, but they introduced a new feature called Tri-Mode to support NVMe. For this generation of controller, Broadcom's documentation is very vague in terms of performance or the IOPS performance. They basically say that this chip was better than the previous generation. And so the previous generation being, hey, greater than 1 million IOPS, I basically wrote down greater than 1 million plus question mark, so it was very vague. So that's why I wrote it down this way. Now, running in PCIe 2.0 mode, we got 820,000 IOPS. And so we are a little bit short of that million. And this might be because we're running in PCIe 2.0 mode. And the bandwidth number we got was basically about 3.3 gigabytes. The power consumption number was very interesting. They're kind of changing the way they're specifying the power consumption now. And from this generation, instead of mentioning a nominal versus worst case, they just say typical. So typical power consumption. And they specified 10.05 watts. We measured 6 watts at idle and going into the 7 watt territory under load. Now, this is significantly lower than their typical power consumption of 10.05 watts. I might speculate a little bit that maybe we are using a little bit less power in this case because we're running in PCIe 2.0 mode. But I don't imagine that running in PCIe 3.0 would significantly change that number. I think maybe you could add a watt or two, maybe. But that would still come in fairly significantly lower than the specified 10.05 watts. So the next row here is where I reran the test running the card in PCIe 3.0 mode. Now again, in this mode, I'm not able to measure the power consumption because I had to install it without that interposer to measure the power. I think the IOPS numbers and bandwidth numbers are a little bit more interesting in this case, at least more comparable to the other numbers that we measured. And so we came in at about 1.4 million IOPS which, you know, I guess their claim that this is better than the previous generation. And so if the previous generation, as we saw here, was 1.2 million IOPS, this definitely did accomplish that. And so their documentation was correct in that sense, even though it was very vague. We got a bandwidth number of about 5.9, roughly, you know, almost 6 gigabytes per second there. And so this is, again, running in PCIe 3.0 mode. The next row here, we basically was the same card again, but running in PCIe 2.0, but instead of running the 4K random reads, I ran the 2K random reads just to see if I could boost the IOPS numbers up a little bit more. And we got roughly about 1.5 million IOPS and about 3 gigabytes per second. And again, in that case, the power consumption was basically roughly the same, idle at 6 watts, going into the 7 watt territory as we put it under load. Okay, so moving on to the last row here, this is the SAS1068E chipset, or the 9500-8i controller. And this is the first generation to support PCIe 4.0. Now, I have to mention that we're running PCIe 3.0 because that motherboard doesn't support PCIe 4.0 yet. And this is the generation that supports SAS3, 12 gigabits, again, has the tri-mode feature, and is based on the ARM architecture. Okay, so as far as IOPS numbers go, this controller is specified to handle 3 million IOPS. We measured 1.42 million IOPS. And I think this is primarily not a shortcoming of the controller, but a shortcoming of the SSDs that I'm using. Basically, I think, you know, the 1.4, 1.5 territory is pretty much maxed out for those 8 SSDs that I have. So take this number for what it is. I don't think this is any indication of the performance of the controller, but more of the limitations of the SSDs that I'm using. And we got a bandwidth number of about 5.8 gigabytes per second. Now, the power consumption is, I think, very interesting here. So the specified power consumption in the documentation is typical power consumption, 5.96 watts. So we measured 4 watts at idle, and that boosted to 6 watts under load. And so this is probably the most dynamic power consumption numbers that we've measured so far, basically going from 4 to 6 watts, which is a 50% boost in power consumption. All the previous numbers, basically, we kind of added like an extra watt, and it didn't really, you know, it wasn't significant really. This is, you know, I think a little bit more significant. So maybe there's some sort of power throttling designed into this chipset compared to the previous generations. And so at idle, it can sit at a much lower power rating, power consumption at 4 watts, and under load, it goes up to 6 watts, which is actually almost spot on to the specification of 5.96 watts. So anyway, those are the numbers. And as you can see, the power consumption increases from the first generation all the way to the 4th generation, peaking at the 4th generation, and then starting with the 5th and, or actually, this is actually the 6th. There's a 5th generation card that's not in this table. But starting from the 6th generation onward, using the ARM architecture, we can see that Broadcom is bringing down that power consumption while achieving better and better performance numbers. It's actually pretty incredible if you look at the last generation here versus the first generation. We're basically talking about power consumption that's very comparable, and yet we're talking about orders of magnitude difference in performance from 140,000 IOPS all the way to 3 million IOPS. So I think that's definitely advancement in technology over the generation. All right, that wraps it up for this video. If you're interested in the power consumption of 16 lanes or 24 lanes or even the 4-lane SAS controllers, stay tuned for those videos in the upcoming weeks. If you found these results interesting and helpful, please let me know down in the comments and give this video a thumbs up. If you're new to this channel and you like this sort of stuff, consider subscribing to the channel. Also, if you want to support my channel, check out my eBay store. I've got the best selection of pre-flashed HBAs for your TrueNAS, ZFS, or Unraid server builds. Go check out the link down in the video description. Thank you very much for watching and have a great day. Bye-bye.